Guys, welcome to this new board revision series. So as you guys know, your board exams are like right around the corner. I think it's going to be in 20 days. So my goal for the next 20 days is to just post a video almost every day, summarizing 2 or 3 chapters or so. I'm just going to be doing like 4 or 5 of the most important questions from each chapter. My goal in these videos is that you just get a revision without actually doing these questions. You just understand that, the board follows the same pattern and you're going to expect like similar questions as the ones that I'm going to be doing today. So in today's video, this is going to be the first episode of the series. I'm going to be covering 2 chapters. I'm going to be covering ratio and proportion as well as inequalities. So inequalities is relatively easier. So I just decided to do one question. I'm going to be doing a lot of questions from proportion though. So yeah, without any further ado, let's begin. This is a bit difficult. So let's start with something easy. Now see, there's just 3 kinds of questions that come from proportion. Number 1 would be general questions like this, where you have 4 numbers. They have to be in proportion. Or, we have relationships between certain numbers that are in proportion. You have the means, extremes, mean proportion, continued proportion. What number is third proportional to these numbers? Then they're in continued proportion, right? So questions like that come for MCQs and sometimes for 3 markers. So that's one type of question that comes. Another one is using properties of proportion to find x, most likely component or dividendo. That's the second type of question. Not always to find x, but yeah, to find whatever. Finding x would always be helpful. And then the third kind of question is just to prove certain identities, certain equations using, again, properties of proportion, or just other methods, as long as we know that certain numbers are in proportion, certain values are in proportion. So let's start with this one. What number should be subtracted from each of these numbers? So 23, 30, 57, 78. Now these 4 numbers would be in proportion if there would be a number subtracted from each of them. The only criteria is that the number doesn't change, so it's the same number in all 4 cases. Obviously, we just set up an equation first. So we have 23. 23 minus, let's take a number to be alpha, over 50 minus alpha. This would equate to, sorry, not 50, 30, my bad. So 23 minus alpha over 30 minus alpha would equate to 57 minus alpha over 78 minus alpha. So these are the basic, this is the equation that we have. Now solving it can be done in multiple ways. You can take LCM over here, you can do whatever you want, you can distribute. Although those will be a bit long, you can still do that. When you distribute, you'll realize that you have a quadratic, but then it's not going to be a quadratic at all because the coefficient of x squared is just going to be 0. So it's going to be a linear equation at the end. So you can solve it however. Either you can distribute, like I said, or you can just directly use component to dividend here, which I feel is very helpful. So I'm going to do that. 23 minus alpha plus 30 minus alpha divided by 23 minus alpha minus 30 plus alpha equates to 57 minus alpha plus 78 minus alpha divided by 57 minus alpha minus 78 plus alpha. Remember the signs change, okay, because there's brackets over here. This cancels off with this and this also cancels off with this. 23 plus 30, 53. 53 minus this 2 alpha. Got it, this 2 alpha over 23 minus 30, negative 7. This is going to be equal to what? 57 plus 78. Okay, 57 plus 78 plus 57. How much is that now? 15. So 135. 135 minus 2 alpha over, this is negative 21. Okay, so this gets cancelled with this goes here thrice. 53 multiplied by 3. This is 159. Okay, so you obviously distribute, cross multiply, so 159. 159 minus 6 alpha. And then you can get this also here, plus 2 alpha equals to 135. So 159 minus 135. 159 minus 135. This would just be 24. Okay, so since this is 24 and there's 4 alpha basically remaining here, it becomes 4 alpha because it goes there. 4 alpha would be equal to 24. Meaning that alpha is just 24 by 4, which is 6. So this is a very easy method to solve this. You don't really need to do much. You just need to cross multiply, set up an equation, and then you can get alpha directly. This is a shortcut for calculations, so don't distribute it. Use component to dividend. Okay. Just because they don't mention use properties of proportion doesn't mean you can't use it. Use it. It'll be better off if you use it. Coming back to this question. Now I told you they'll give you certain problems where you don't really need to do much. You don't even have to think, just like the one that we did. But there's also some problems that require some sort of thought process. Like for instance, we have this one. So you can substitute this over here, 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 but that will be absurd. It'll take forever. So clearly we're not doing that. There has to be some shortcut. Well, we already have one hint, right? This is in the form x plus y over x minus y. Whenever you have x plus something over x minus something, just know that over the component to dividend would be used. So what we're going to do is we're going to do a small little algebraic manipulation over here. We're going to divide x by 2 root p. Because once we do that, right, once we do that, and you apply component to dividend here, this becomes x plus 2 root p over x minus 2 root p. And since we're dividing this by 2 root p, we also divide this by 2 root p. Okay, we also divide this by 2 root p, essentially. So you apply component to dividend here also, and then you get some expression. And then you do the same with 2 root q, and then you get another expression. Just add those 2 expressions and then simplify. Okay, divide x by 2 root p And so you're also dividing this expression, which is 4 root p root q over root p plus root q divided by 2 root p. So these two terms cancel. This cancels off with this twice. So x plus 2 root p. Now you apply component dividend. X plus 2 root p over x minus 2 root p, okay, would equate to, now this is 2 root q plus root p plus root q, okay, over 2 root q minus root p, okay, minus root p minus root q. And now you can obviously simplify this further. So x plus 2 root p over x minus 2 root p would basically just be what? 2 root q plus root q, 3 root q. 3 root q plus what is left here, root p, upon, again this cancels off here. 1 root q gets cancelled off. So it's just going to be what? Root q minus root p. Yeah, that's it. This entire thing has just become this. Okay, so you do the same thing with root q this time. 2 root q this time, you divide by 2 root q. So same exact thing. X divided by 2 root q this time. 2 root q would equate to 4 root p root q. What am I doing basically? I'm just putting it in this form. Based on the question, remember this can change. If this wasn't 2 root p, if this was simply root p, I would have divided this also by root p. Are you understanding? It's based on the question. It's based on what, this is a manipulation based on the question. This makes the question easier. This is why I'm doing this. So 4 root p root q and then root p plus root q. Now again, just apply the trick. But then sorry, you've also forgotten to divide this, right? So you do that as well. This goes here twice and this cancels off. Okay. Now again, using component of dividendo, this is x plus 2 root q over x minus 2 root q. Because this is what has been given here, okay, and this is what has been given here. That's the reason I'm doing this in the first place. Okay, I also want you to understand why I'm doing this rather than how I'm doing this. So this is 2 root p, okay, this is going to be 2 root p plus root p plus root q over 2 root p minus root p minus root q. Okay, 2 root p plus root p, this is going to be 3 root p. So x plus 2 root q over x minus 2 root q would basically just be 3 root p, okay, 3 root p plus root q upon, this is going to be root p minus root q this time. Okay, so root p minus root q. And now you're just supposed to add these two terms. You're supposed to add these two terms. Now one thing though you can notice is that these two terms are like very similar, but p and q in a way has just been interchanged. Right? P and q in a way has just been interchanged. So in the denominator of this term you have root q minus root p, and over here you have root p minus root q. So what you can do is you can make one of the terms negative, so the denominator is like multiply and divide by minus 1. You multiply and divide this term by minus 1. Okay, so minus 1, minus 1. So this becomes minus 3 root p minus root q upon root q minus root p. The reason I'm doing this is because now the denominators are the same. The denominators are the same, so now you can just add this. Add this expression. So 3 root p plus root 3 root what? 3 root p plus, is it root p plus root q? What? I think I made a mistake here, if I'm not wrong. Yep, I definitely made a mistake. It should be 3 root q, okay? My apologies, you guys. This is why I hate using p and q as variables. Anyways, so this is 3 root q plus, what is that? Root p, right? My apologies, my sincere apologies. And you divide by same denominator. So root q minus root p. Yep. Okay, got it. Now you can obviously do that because the denominators are the same. So this just becomes what? 3 root p, okay, or 3 root q minus root q. 3 root q minus root q, yep, minus 3 root p plus root p. And you're just dividing by root q minus root p. Okay, getting them mismatched. So root q minus root p. Yeah. And now you can factor 2 out. Essentially, you can just factor 2 out. So this is root q minus root p divided by, again, root q minus root p. And there, this gets cancelled off. And all you have left is 2. This is how you solve the sum. Obviously, this is complicated, as you can see. It's not actually, you just put it in this form and then you use component to dividendo and then you just add these two expressions together. And then you can factor whatever is common and then you'll get 2. Okay. So I get why this is a 4 marker. I mean, even I got confused with the p and q and all, but apart from that, I got the answer at the end. Okay. You just be very like locked in when you solve a problem like this, so you don't lose like step marks. But yeah, I think this is easy. Okay, it's easy, but then it's also a bit complicated when you do it for the first time. So yeah, these two problems I hope you've understood. Let's do this one. This also looks pretty important. In cases like this, you always use K method. Always use K method. It works. Trust. Okay, just trust me. K method works a lot for this. So what is K method basically? When you have something like this, a over x equals b over y, okay, equals c over z. You let this equate to k. And when you cross multiply, a is basically equal to kx, ky, and c is equal to kz. Okay, got it? And now wherever you have a, b, and c, you just replace it with these things. I think that's the like main goal for this. You know what I'm saying? So if you have a cubed over x cubed, okay, a cubed over x cubed, b cubed over y cubed, and all that. Yeah, so that's what you basically need to be doing. Okay, so the first thing that I can even think of is just replacing these. So this is kx. Okay, this is kx cubed, because a is kx over x cubed, plus ky cubed over y cubed. Okay, pretty straightforward. Plus kz cubed over c cubed. Okay, start off at LHS always and then modify RHS also accordingly. So basically you can remember, you can do this when you have exponents. So k cubed x cubed over x cubed plus this is what, k cubed y cubed over y cubed plus k cubed z cubed over z cubed. Now you can cancel whatever's common. So you basically have 3k cubed left. You have 3k cubed because it's basically k cubed plus k cubed plus k cubed. So that's 3k cubed. You make sure you also have 3k cubed in the RHS. Okay, try doing that. So 3abc over xyz. So 3abc, this is RHS by the way, over xyz. Don't do anything over here, just substitute all this in place of a, b, and c. So k, there's going to be 3k's, so k cubed, okay? And it's basically just xyz divided by again xyz. And these terms cancel off. So again, you have 3k cubed. And that's it. Okay, LHS matches with RHS because both of them come out to 3k cubed. So using the k method in this case is a shortcut, okay? But it's not always a shortcut. Whenever you have questions where you have a continued proportion, never use k method for that. That's my advice. In cases like this, use k method. But for continued proportion, my advice is just to cross multiply because that works. Okay, let's do one more like proof. Okay, we'll do the like numerical type questions at the end. Like for instance, you take this one, x, y, and z, and then you need to prove this. So if they're in continued proportion, first of all, it will be x over y equals y over z. So y square equals just zx. Okay, this is all that you need to solve this. You don't need to use k method. You don't need to like introduce yet another variable, which is k. Okay, so all you need to do is wherever you have y square, just replace it with zx. So this is just going to be x over what? Y square is zx, so zx. Z times z square is z cubed times x, so x gets cancelled. Similarly, y divided by, now z square, x square is what? X square is what? Or what you can do is you can just take the zx together, so there's going to be a zx remaining, okay, multiplied by another zx, okay? Zx is just going to be y squared. And yeah, this is also y squared. And one y gets cancelled, so all you have left over here is just 1 over what? Y cubed, right? This is 1 over z cubed. 1 over z cubed. And this will be what? See, y square is again zx. So this is just going to be zx, so this cancels off, times x square, which is just going to multiply to form x cubed in the denominator. So yeah, that's all you have. 1 over x cubed, 1 over y cubed, 1 over z cubed. They're getting added up. So you've not used the k method at all for this. You just cross multiplied it and then it worked. So this is what I would recommend for problems that are in continued proportion, where the numbers or values are in continued proportion. Don't ever use the k method. Just cross multiply. I'll give you another example. So you scroll down here. Okay, you scroll down here. This time A, B, C, D are in continued proportion. So the first step is to set up an equation. This is a 4 marker, by the way. It came in either the improvement paper or the specimen paper. I forgot, but yeah. Okay, so A over B equals B over C equals C over D. I mean, you could use the K method if you're really not able to solve it, but then, you know, the thing about math is that if something is not going your way, you physically like make it go your way. So you just observe the pattern over here. You try to see what you need to do in order to prove it. Okay, so basically, in order to prove it, you just need to make the LHS and RHS come out to the same thing. Okay, so if you cross multiply, B square equals AC. And then you have C square equals BD. That's when we have taken this and this together and this together. But what if we take the first term and the second, or the third, sorry. You equate the first term and the third term, you cross multiply it. What do you get? AD is equal to BC. AD equals BC. Right, so that's the first like observation, and these are 2 other observations that we've made. So these are 3 observations. Using these 3 observations, essentially our goal is to simplify this or solve this, or prove that they are equal. So first I'm going to start here at LHS. Okay, I'm not going to do much. I'm just going to put BC in place of AD because we have AD here. So I'm going to put BC in place of it because we know it's equal. And this is just going to be C square plus D square. Okay, this is all I'm doing to the LHS, nothing more. And then now to the RHS also, I'm not going to be doing much. I'm just going to make use of these 2 things because we made use of this. Now, C cubed. Okay, C cubed. First, what I'll do is I'll distribute it. So this is BC cubed. Okay, BC cubed plus this is just going to be what? DC cubed. Now you need to be smart about what you're going to be doing here. You need to get this to equate to this somehow. Okay, so if you take a BC out, then you have to be left with C square. But that's already happening in the case of the first term. If you take BC over here, you just have C square left. So you need to change this. You need to kind of write this in terms of, BC. How are you going to do that? Such that you can take BC common. So in that case, we're going to use one of these. So This we can also write as dc times c squared, right? Dc times c squared. We can obviously do that. C squared is bd. C squared is bd. So bc cubed plus dc, okay? And this is bd. So I can take bc over here, and then, all you have left over here is d squared. And now this can be written as bc times c squared plus bc times d squared. And now you can again take bc common. If you take bc common, you have c squared plus d squared. And that's exactly what we have here. So we have proven that they are equal. Okay, we proven that LHS is equal to RHS by doing literally nothing. This is all that we needed to do. Okay, so you don't even need K method for this. My advice is whenever you have A, B, C or A, B, C and D that are ever in continued proportion, don't use K method. Okay, don't use K method. If it doesn't work, then you go for it. Otherwise, don't do it. That's an advice I'm going to give you guys. Okay, so this is an important advice. See how easily I've proven this. It's a 4-marker question. It's a joke. But if you use K method, you would have equated this to K. Obviously, you would have done a very long substitution and all that. You would have still gotten, the correct proof and all that, but it would have been long. Definitely long. Okay, we've done all this. Okay, so let's do one of these now. Or let's do both of these. Let's go. This is such a simple question. Another very simple question that comes is to prove that A, B, C, D are in proportion. So one thing that you can do is you can just obviously get this here, invert these things, okay? Or whatever it's called, altering, inverting. So 7a plus 3b, just cross multiply, get this down, 7a minus 3b. 7a minus 3b, okay? This would equate to what? 7c plus 3d, I've gotten that up, 7c plus 3d over 7c minus 3d. Okay, 7c minus 3d. And now, this is just in the form of component to dividend. We are going backwards. So we're writing the original, ratio, which is basically original proportion without using component to dividend. 7a over 3b equals 7c, okay, 7c over 3d. And now, basically multiply both sides by 7, or divide both sides by 7, multiply both sides by 3. So you just get a over b equals c over d. And they're in proportion. This is what you can do, okay? This is one way of solving this. Another way is to go backwards. You start off with this, and then you multiply both sides by 7, divide both sides by 3, and then use component to dividend, and then you get this. So it's your choice, but sometimes very easy questions like this can come, okay? Or this can also come as an MCQ, like they'll say, okay, A, B, C, D are in continued proportion, and they'll say assertion, this, reason, component to dividend. So both A and R are true, okay, and R is the correct explanation. So you can very easily get an assertion reason-based question like this, or, it's so easy that you don't even need to show this as a 3-marker. You can get multiple different statements and say, okay, which is the one that's true or which is the one that's not true. So you need to identify. Let's do this one. I see why this is a 4-marker because you're not asking you to find X directly. But, I get the point. And you also need to use identities. Obviously, just use component to dividend over here. So you have X cubed, okay, you have X cubed plus 3X squared. So what you do is you add this plus 3XY squared plus Y cubed, okay, upon X cubed plus 3X squared minus 3XY squared minus Y cubed. And now that you've done this, you have to do the same thing over here. Component to dividend. 91 plus 37 over 91 minus 37. Don't pay attention to this right now, okay? You're not doing that right now. You're just finding X. And now, X cubed plus Y cubed. And what can you take common over here? Wait, sorry, this is 3X squared Y. I don't know why I didn't write that. Again, my sincere apologies. So, yeah, X cubed plus Y cubed plus, if you take 3XY common, you have, again, X plus Y. This is an identity, right? The X cubed plus, X plus Y whole cubed, my bad, X plus Y whole cubed. A cube plus B cube is different. A cube plus B cube is A plus B times A square plus B square minus AB. That's different. This is A cube. This is not A cube plus B cube. It's A plus B whole cube. And as you can see, the denominator, you have A minus B whole cubed, which is going to be X minus Y whole cubed. Okay. Now, you have to get these two to also be perfect cubes. So, 91 plus 37. There's 8 here. So, this is 128. Okay, this is 128, which is not a perfect cube, over 91 minus 37. Okay, so 11 minus 7 is 4. 8 minus 3 is 5. 54. 54. But they both are divisible by 2. 2 goes how many times? 64 times. 64 is a perfect cube. What about this? 2 and 7. So 27. So obviously these 2 are also perfect cubes. 64 is 4 cubed. Okay. 27 is 3 cubed. So you can just cube root both sides. Take these off. X plus Y over X minus Y equals 4 over 3. Again, use component to dividend over here. X plus Y plus X minus Y. Okay. Over X plus Y minus X plus Y. You don't need to really do it twice, but I like to do it twice. Okay. 4 plus 3 over 4 minus 3. Got it? So this will be what? 2x, because these two terms get cancelled and these two terms get cancelled. 2x over 2y would basically be what? 7. Okay, 7 by 1, which is just 7. So x by y is 7. So I've not found x, I've found x over y. Okay. So what are they asking for? X plus 2y over x minus 2y. Huh? So if you were to divide both sides by 2, this will be x over 2y. If you also divide this by 2, then again you apply component to dividend here. X plus 2y over x minus 2y. If you apply component to dividend here, this will basically be 7 by 2 Okay, so sorry, 7 plus 2 over 7 minus 2. 7 minus 2, which is just going to be 9 by 5. And that's it. X plus 2y over x minus 2y is just going to be 9 by 5. Okay, so I completely understand why this is a 4-marker question. Okay, so you've simplified this, you applied the a plus b whole cube, a minus b whole cube identity, then you first got an x by y equals 7, and then you've done this thing as well. And plus you had to apply like complement to dividend twice. You didn't have to do it, but then, you did do it. So I agree that this should be a 4-marker. So if it comes as 4-marker, I expect you guys to be able to do this now. Okay, so we've done all like proportion related questions. These are the ones I felt are important and expected for the 2026 board exam. So just do these questions properly. Okay, do similar questions in your textbook. There's many more questions. Okay, there hasn't been like a proof in a while, like using K method or using just cross multiplication. There hasn't been a proof. The last one that has ever come was this one, which one? Sorry, this one, right? Which was in one of the specimen papers, I forgot. And even this one had come. So there's a chance that in the 2026 paper you can see, a proof like this. Remember what I told you. If it's continued proportion, don't use the K method. If it's not, if it's something like this, okay, if it's something like this, then you can use the K method. Okay, so now let's do the inequality question and then we'll wrap up this session. Okay, so we've got this inequality. This is a classic like question that comes. The reason why I just plan on doing one question is because this is literally all the practice you need for this chapter. There's nothing much you can do. There's only one type of question that comes. It's been coming for the last 15 years. It's not going to change. We can't really, throw you off with application in this. So this is all that they're going to give you. They're going to give you a double inequality. You need to solve it, graph it on a number line. So you deal with this thing first and then this thing. And then you combine it, form one solution set for 3 marks. And then obviously plot it on a number line. First thing you do is you get the x's together. That's my biggest advice. So if you want to do this one, let's say you want to do this question, this part, sorry, you want to do this part first. You get this 2x by 5 over here. So you make this 3x minus 2x by 5, okay, is less than. 16 comes here, becomes plus 16, so 16 minus 3. And now you just take LCM, so what is it going to be? 15x minus 2x by 5, okay, is less than, this is 13, okay, 13 into 5. So 15x minus 20 minus 2x is less than the 65, okay. So this is 13x is less than 65, making x be less than 5. So 5 is greater than x, or x is less than 5. This is one part that we've gotten. So the next part should include this one as well. Okay, it should include this one. Now you solve it basically. You solve it. So 2x by 5. Okay, and you get this 2x also here. So minus 2x. Okay, minus 2x less than or equal to. You get this 3 over here. So 3 minus 3 by 5. And that's it, you solve it. See, if you want to just like directly take LCM, you can do it. For me, I find it easier to get the x's together and solve it. Okay, again, you guys are free to do it however you wish. Okay, as long as you're just getting it right. Because people make mistakes when they don't group the x's together. And now the 5 just gets cancelled off. So it becomes negative 8x. Okay, negative 8x is less than or equal to, what is this going to be? 12, right? 12. So negative 2x, okay, is less than or equal to 3. Basically divided both sides by 4. Okay, so x is greater than or equal to negative 3 by 2. Yeah, that's it. Inequality sign changes, don't forget that. Okay, so x is greater than or equal to negative 1.5. Remember, this chapter is just like solving linear equations, but the only thing is that the sign changes. Inequality sign changes based on what you're doing. If you're multiplying or dividing by a negative number or just reciprocating both sides and all that, remember that you need to change the inequality sign. That's the only thing. So x is greater than negative 1.5, okay, and x is less than 5. Greater than or equal to, sorry, or equal to this. Okay, so this becomes your solution set. And of course, x is a real number. Okay, so plotting it is the easy part actually. As long as you've gotten this right, you can plot it. So begin plotting it. Basically, x is greater than or equal to, right? X is greater than or equal to, so you take this and then you shade this circle properly because it's greater than or equal to. And it's a real number, so it's just before, like just it includes it. Okay, but then since x is less than 5, we also just like circle 5, but we don't shade it because it's not, like it doesn't really belong in the thing. Okay, it doesn't really belong in the thing. And now we've got to just like create another line. That's it, we just gotta plot it, I guess, this way. I'll just use a line then, not an arrow. Okay, yeah. And that's it. You can just shade it a little bit if you want, like this. So this is how we have done it. Okay, if you think that you can do it in a different way, do it. I don't think they really care about this much. As long as you're just following these rules, it doesn't matter. Okay, it really doesn't matter. This is the method on solving it. So this is the most like generic question that will come from this chapter, nothing too fancy. For an MCQ, maybe it'll be an easier inequality, not something too difficult. Okay, that's it. So this chapter comes for like 3 to 4 marks every year. And this is the only question that comes, and it always comes like this. There'll be zero twists from this chapter, zero application. I'm just ensuring that it'll come like this. Okay, I'm ensuring you that it'll come like this. So this is all the revision that you need from this chapter. There's nothing more that can be done from my end. So that's all for this video. Okay, there's nothing more to be done. In the next video, we'll be moving on. We'll be doing 2 more algebra chapters, and maybe we'll be moving on to commercial mathematics. Then we'll get to geometry. The similarity to be done, there's circles and more stuff like that coming up. And then of course trig has to be done as well. So thanks so much for watching. I hope you guys have a good revision. Okay, keep studying. Okay, you'll do very well in boards if you just lock in for the next 1.5 months. Just focus on studies, and then everything will just go your way. Okay, if you work hard, you'll definitely be happy. Okay, just keep working hard. Stay motivated. Don't lose your motivation. Don't lose your interest. Be dedicated, and of course be consistent. Every day study. Okay, so thank you so much for watching. Bye.